Oh, g'day, how you going? It's Mr. Bennett here. Today we're going to be looking at a PowerPoint presentation and then an animation. So what we're going to do is going to go through quantities, the units, vectors, the concept of a vector. We're talking about displacement again. We'll be looking at some examples of velocity, acceleration, and then kinematics, which is obviously the study of motion. And then we'll be looking at some motion graphs in 1D. Alright, so if you look at a vector, vector has quantity and size, and then your scalar quantity only has a value. So what we need to look at there is examples of vectors. So displacement is a vector quantity, velocity, acceleration, momentum and force, where these other things like distance, speed, time, mass and energy are all scalar quantities. Right? So you need to probably recognise those as being vectors and scalar quantities. Right, so when we start looking at things like mass is a scalar quantity because it doesn't have obviously a direction associated with it. It's just how heavy something is. Where weight is affected by gravity, so it's a force of gravity on an object. So if you went to say the moon, you would probably still have the same mass on the moon, but because it's got 1/5 the gravity that Earth has, then your weight would be 1/5 of what it is on Earth. Right? So there's some examples there of how those relate. So vectors, we generally indicate a vector by having an arrow, and the arrow points to the direction that vector goes. So this would represent a vector going at 42 degrees above the horizontal at 5 meters per second. Right? So units are not always the same as quantities. So things like we've got displacement and distance, we both measured those in meters and they've got the symbol m. Where we've got velocity and speed, they are different, but we'll also both measure those in meters per second, or you might see that as meters per second to the -1. And then you've got the units for acceleration, meters per second squared, and so on and so on. You can have a look at those, right? So the prefixes we've talked about, I'm not going to go through that right now, but that's on your formula sheet, those prefixes. So these being really small units and these being really big units, all right? So remember you've got access to this PowerPoint so you can go through this again. All right, so kinematics is to study looking at motion. Now, position graph, we either call X or you might use the symbol S, okay? But generally X is used, okay? And the change in, obviously that is, change in your distance is what we call the displacement. Alright, so we'll start looking at some of those. We've already looked at this before, but let's just go through this. So if you drive on the path, on your O-Day, it might go up by 8 miles or 8 kilometres, okay? But if you think about how the crow flies, it's not going to be the same distance, is it? So if you start looking at the green arrow, the distance on the green arrow and the distance on the red is going to be different. So the red is in fact the distance that you travel and the green arrow is your displacement for that. Alright, so obviously speed is how fast you're going, velocity is how fast you're going in a particular direction. Alright, so the average speed is your distance over your time and your acceleration is how fast you're speeding up or slowing down. In other words, you are changing your velocity over a period of time. Alright, speed versus velocity. Now I'll just flick through this really quickly. Speed is a scalar quantity, so if you're going at 20 miles per hour, that's the magnitude of the velocity, where if you're looking at your velocity, it'd have to be 20 miles per hour in a direction. So in this case here, it is 15 degrees southwest. Alright, so I'll just flick through this to do that. Acceleration, obviously, if you're speeding up, then you have a positive acceleration. If you're slowing down, then you have a negative acceleration, what we call a deceleration. Alright, so here's an idea. So if you've got a positive velocity and a positive acceleration, then that would mean that you're moving forwards. That would either be going in the positive direction to the right or going up. And it means that you're getting faster, you're speeding up. If you've got negative velocity but a positive acceleration, means you're moving either to the left or you're moving downwards and you're slowing down. Alright? If you're moving in positive velocity and you've got a negative acceleration, that means you're slowing down and you're moving the forward direction. And if you've got a negative, that means that you're moving backwards and you're actually speeding up. Right, so looking at that over there. So acceleration due to gravity, near the Earth's surface, we know that gravity is about negative 9.8 metres per second. So it's a vector quantity, it's directed downwards. Alright, so quite often we use the idea of 10 metres per second. Now, if I haven't shown you these formulas, we will certainly go through these. We've either been through these or something similar to this. Alright, so I'm not going to go through that and do the proofs. You can have a look at those at your own leisure. I'm just going to flick through this quickly. Not going through this. I want to start looking at the graphing notion. So this is a position versus time graph because it's got x on the y horizontal on the y-axis and t for time on the x-axis. So because this is going in a straight line, this represents starting at your home base or the origin and then moving forward slowly at a constant rate of change. Okay, in other words, you've got your velocity is constant there. Part B would be representing that you're stationary, so you're not moving. And then part C means that you're moving back towards your origin. So in other words, turn direction around, and then it means that you're moving at a constant velocity. You go past maybe your original position and you keep moving maybe to the left. Alright? So graph width here. Okay, so this has got some acceleration on it. So this is, again, position versus time graph. So from part A to part B means that you're starting either south or left of the reference point. It means that you're increasing your speed gradually because it's getting faster and faster, isn't it? Okay, so part B, you've actually passed home and you're gradually slowing down. Okay, to a point where you would probably stop and you're north of the reference point. C, you're turning around and you're gradually speeding back up again, and you're going to go past through your rest position, and then part D, you're going to continue going south, but you're slowing down and you're going to get to a point where you're probably going to stop. Alright, so if we start looking at your tangent lines to that graph, okay, so in the first position over here we have a positive slope. Okay, it means that the velocity is positive. Here you've got no slope, so that means that you've got no velocity. And here you've got a negative slope, so that means that you've got a negative velocity. Okay, so if it's steep, if that gets steeper, it means that you're speeding up. If it gets basically flat, it means that you're not travelling at all. And if it's getting less steep, that means that you're slowing down. So you can get the concept of how you could use your tangents to the graph to give you an idea about that. Right, so on here, this graph here means that on this position here, it means that you're increasing. Right, this is the position time graph again. So the blue bit means you're moving forwards in the positive direction. Okay, and the red bit means that you're moving in the negative direction. So that would mean either going north, and that's coming south. That's going to the right, and that's coming to the left. Okay, that's going up, that's going down. So we're using that sort of concept. Okay, on the position time graph over here, okay, so the concave bit means that you've got a positive acceleration. Okay, so here you've got concave up. Okay, and you've got a positive acceleration there, concave down, which means that you've got the negative acceleration. Alright, we'll just keep flicking through this, so I'm going to go to the next graph over here. Okay, so if we're looking at this graph over here, we don't have constant velocity. So in other words, our velocity is increasing here to a point. Okay, and that's a maximum speed that the velocity is going at. So now our velocity starts to slow down. Okay, to that point there where the velocity is going to be 0. Okay, so it's still positive, but it's actually slowing down. At this position here, we've got a negative velocity because it's moving downwards or to the left. So it starts off slow and it's increasing to this point here where it's going to be at a maximum, and then our velocity starts to slow down over here. Now what you would say about this, because you've got constant velocity, means that our acceleration has to be constant, doesn't it? Okay, so that's a positive acceleration. Because it's got a negative velocity down there, and it's slowing down. Okay, we've got a negative acceleration, and here, right, because it's now moving forwards again. Okay, it's going to have a very small positive acceleration. So graphing, I won't worry about showing you an animation. I'll flick onto the next page very quickly. So some tips about graphing. Right, the idea is that you probably draw these vertical lines. Now probably most of the time we'll be working on grid paper, so you'll better see that. So that allows you to line up these special points, okay? So map the slopes of the position graph with onto your velocity graph, okay? So in other words, you can do your tangent there, so you get an idea what the tangent might look like. Read on the red peaks or the valleys means they're going to be intercept points, okay? So that's got to be when you've got to have zero velocity, okay? So you've got the idea there. Here you're going to have zero velocity because it's a minimum. Zero velocity, it's in a minimum, all right? So, and these points correspond to the biggest slope, so therefore they're going to be your maximum points here. All right, so the same rules apply for any acceleration graphs, velocity graphs, okay? Doing the same sort of thing there, and you've seen that graph already. All right, so in real life, a lot of these graphs are smooth and they change around a fair bit, so you just need to be aware of that. Now the other thing that we can do, if we start looking at a velocity versus time graph, we can actually work out how far you've actually travelled, your distance travelled. So what you do is you work out the area under the curve, because that's a triangle. You can work out the area of that triangle, the red bit. You can work out the area of your purple bit. So the difference between those two, the net area, is your net displacement. Now if you're looking at the distance that you travel in total, you've travelled that way, and then you travel this distance, so it's got to be the sum of the red area and the sum of the purple area. Alright, so you can get those two terms that we've talked about from that particular graph there. So the areas above and below don't have to be equal. If they are equal, that means that you aren't going to have zero displacement, but you certainly would have not a zero distance travel, would you? I'll just click through that. So here is another graph that shows you a ball being thrown up. So position starts there, gets up to its maximum position, then it starts to come down. Now we know when that happens, it's going to be fairly symmetrical, this graph. Now what happens here is once you've thrown it up, the velocity of this particular ball is going to be still moving in a positive direction to this point here, okay? But it's slowing down the whole time, okay? And then here, it's going to start off slowly, but it's going to increase its velocity. So it's going to be travelling under what we call constant acceleration. The acceleration is going to be negative 9.8 metres per second squared. All right, so that would be the graph, a motion graph, or something that would represent a ball being thrown up. Alright, so here are some other ones that you can have a go at doing if you want to have a go at doing those. I know there'll be plenty of questions for you to have a go at doing. So I'll just end that here. Alright, you can have a look at that PowerPoint yourself. Just want to show you a graph of a man walking, and we've got its position, velocity and acceleration. So if I play that, alright, you can see the acceleration is very low at, just pause. So you can see the acceleration is constant at 5 metres per second. Okay, so therefore, if it's got constant acceleration, the velocity is going to increase at a constant rate, and its position is going to also increase over here. But that's going to work as a curve graph. Now I can just reset that, and I can show you. Now, if I move him, you won't get constant. You won't get constant velocity, but you can see. I'm sort of jerking it a little bit as I'm walking back and forth. I'll just stop that there. But you can see if he's moving in to the right, then he's got a positive velocity. As soon as I start to slow down, that point there represents a change in direction. Okay, it's changing direction there because he's slowing down. Okay, so I'm still moving to the right. Okay, at that point there I've stopped and now I'm moving to the left. So as he's moving to the right, you'll notice that the velocity is positive, even though, because I moved it, it was a little bit jerky. You've got these things here, but when he's moving to the left, this corresponds to moving to the left, he's got a negative velocity. Okay, when he's moving to the right, he's got a positive velocity. When he's moving to the left, he's got a negative velocity. Get the idea? We're going to play with that in class, and we're going to use some motion sensors, and we'll get you to actually experiment with that and talk about that. All right. So I hope if you want to have a go at doing this on this particular app, all you need to do is go to the FET site. It's on your program, and you can have a go at this one called the Moving Man and play around with that yourself. All right. So I'll leave that there. We will go through some of these examples in class. All right. So it's a pretty easy concept once you get it. But we'll do some walkthroughs, and I'll do some modelling of this in class to help you understand it. So I hope this helps, and have a look at what you've got to do on your worksheet, and I'll talk to you in class tomorrow.